Let's talk about how we name alcohols and then briefly discuss their reactions. So, alcohols can just be thought of as another functional group. They're just another substituent that you need to include in the name of your molecule. The suffix changes to OL, okay, because when you have an OH group, that changes the suffix. So in this example, it's a 4-carbon chain. Now you just need to decide who takes precedence in terms of numbering, the OH or the CH3. The alcohol takes precedence over the methyl group. Okay, so we want to begin numbering from the right because we want to give the alcohol the lowest number possible. So we want to number this way so that it's 1, 2 as opposed to 1, 2, 3. Okay, so 1, 2, so that's where the alcohol is. It's on carbon number 2. And then there's a methyl group on carbon number 3. Okay, so we're going to think of that methyl group as a guest. So my final answer is 3-methyl 2-butanol. You need to tell the reader where the alcohol group is located. Okay, because it could be 1-butanol, could be 2-butanol. You need to tell the reader where it's located. It can't be 3-butanol because if the OH were here, you'd begin numbering from this side. Now when you've got it in a ring, again, the alcohol is going to take precedence over the methyl group. So this alcohol is number 1, and you don't need the 1 because in a ring we're assuming that the alcohol is on carbon number 1. So all the name is here is 3-methyl cyclohexanol. Okay, the 1 is not needed in a ring because we're assuming carbon number 1 is where the alcohol is located. So only in a ring can you omit the 1. If it's straight chain, you cannot omit the 1. If you've got 2 OH groups, we call it a diol. Okay, so that just means that there are 2 OHs, and you do need to designate where those 2 OHs are, because they could have both been on number 1, right? It could have been 1,1-ethadiol, but it's not, it's 1,2-ethadiol. So just make sure that when you've got multiple alcohols, diol, triol, etc., you just need to designate where they are with numbers. We can also go the other direction, all right? So if I say 2,3-dimethyl 1,6-hexadiol, we're going to draw a 6-carbon chain, and then on carbons 1 and 6 we'll have OH groups, and on carbons 2 and 3 we'll have methyl groups. And then in a ring, 1,3-cyclohexadiol, we just arbitrarily chose carbon number 1 to be right here. So 1, 2, 3, 4. So 4-ethyl 1,3-cyclohexadiol. If we were naming these in class, I would give you a time to do it on your own. So why don't you pause the video and try these on your own. When you're ready to check your work, 1,2,5-octatriol and 7-methyl 1,3,5-cyclooctatriol. These all have 3 OHs. And then we can, again, you can pause the video and draw these on your own and then check your work. There would be 1,2,4-cyclohexatriol, and there would be 5-ethyl 6-methyl 2,2,3-decatriol. If we were doing this in class, I would give you time in class to do it, and then we go over it. But since this is a video, you can pause it and then check your work. The 3 types of reactions of alcohols we're going to look at are combustion, dehydration, and oxidation. Combustion is just a reaction with oxygen, and combustion produces CO2 and H2O. So here's an example. There's 2-nonanol. I had to draw it to figure out the formula, or you can also just imagine it and then count your carbons. Oxygen, O2 is a reactant. You have to have O2 to be a combustion, right? That's why a fire stops when you cut off the oxygen source. And then the products of combustion are CO2 and H2O. So all you need to do is write the equation and then balance it. When we dehydrate an alcohol, we need heat and we need acid as catalysts. So we need to write over the arrow H plus and heat. Okay, we need some sort of catalyst to get this reaction going. And what we do is we're removing the OH and we're removing this hydrogen and we're forming a double bond. So our other product is water. So make sure that you put plus H2O as your product so that we're obeying the law of conservation of mass. All right, Zaitsev's rule applies to forming alkenes from alcohol dehydration. And so the rule is that the alkene that is most substituted, in other words, the greatest number of alkyl groups, is the major product. Now, sometimes Zaitsev's rule doesn't apply. In our previous example, it didn't apply because we had a very simple alkene. But here's a more involved example. So we've got 1, 2, 3, 4, 5. So this is 3-methyl 2-pentanol. And we're going to use warm acid. Now we could form the double bond on this side, or we could form the double bond on this side. Zaitsev's rule says that the more substituted alkene is preferred. So if you look at this side, there's just 2 hydrogens here. If you look at this one, we've got a methyl group on the double bond. So the preferred product, the major product, will be the top one. The minor product will be the bottom one, because the top one is more substituted. If you're doing it in a cyclic molecule, again, it just depends. If this methyl group weren't here, it wouldn't matter, because the top or the bottom, they'd be the same thing. But because this methyl group is right here, I can form the double bond going up, I can form the double bond going down. This one is more substituted, therefore it's my major product, and this is my minor product. All right, the last type of reaction when you talk about alcohols is called oxidation. And the way we represent that is we can just put an O in brackets, unless I specifically state what the oxidizer is, you can just put an O with brackets around it. So a primary alcohol gets oxidized to an aldehyde. So this OH becomes a C double bond O. All right, and H2O is my other product. If it's a secondary alcohol, you're going to form a ketone. All right, so this OH becomes a ketone. And if it is a tertiary alcohol, there's no reaction. Why? Because we don't have a hydrogen on this carbon to oxidize. Notice in the previous one we had a hydrogen here to oxidize, and in the previous one we also had a hydrogen here to oxidize. But in a tertiary alcohol, there is no hydrogen, right? This carbon already has 4 bonds. If this had another bond on it, this carbon would have 5 bonds, so we can't have that. That's not possible. All right, so there's no oxidation of a tertiary alcohol, no reaction. And those are the overview of our alcohol nomenclature rules and our reactions of alcohols.